Good afternoon, everybody, and welcome to this Coffee and Clouds minicast, the longest yard Wi-Fi challenges and solutions. I'm Alan Falcon, the CEO and pragmatic evangelist here at Cumulus Global. I want to thank you for taking time out of your busy day and week to attend this session or to watch this recording. We appreciate your interest in the topic, and we're trying to make this as informative and hopefully entertaining as we can in the short time that we have for these minicasts. As you know, all of the phone lines for those who are on live are muted to avoid background interference with the session here today. So if you are watching this live and you have a question, the icons at the top or right-hand side of your screen will allow you to open a questions window in our system. That's the best way to connect with me. I can see the questions, I can track which ones have been answered, so we make sure we get through them all by the end of the session here today. Feel free to ask questions at any time that you have a question. We also have time for Q&A if needed at the end of the session as well. This session is, as I noted, being recorded. Some of you might be actually watching the recording. They get posted up on our website. We provide access through the website, through social media, etc. Feel free to share the recording with business acquaintances and friends who you think might find the information useful and valuable. As a Coffee and Clouds minicast session, if you've attended this live or you watched the recording, we will send out, if when you registered you indicated a preference, we'll send out a Dunkin' Donuts or Starbucks gift card as a little bit of a thank you gift for joining us here today or for watching the recorded. So with the housekeeping out of the way, since we try and keep these sessions in the 15 to 20 minute range, let's dig into the content at hand. We refer to really Wi-Fi as the longest yard because that is most of your users' actual connection that gets them to your servers and systems internally, as well as to your cloud-based services and the internet as well. And when Wi-Fi first became prevalent many years ago, the issue was, do we have coverage? Can we access the Wi-Fi from anywhere in our office space or anywhere in and around our building, anywhere within our school? As more people started using and relying on Wi-Fi, and we've seen the shift obviously in schools with one-to-one devices, laptops, Chromebooks, iPads, etc. We now have issues with, we started to have issues with density. Not just can we access everywhere, but is there enough capacity everywhere it needs to be so that most of the time, the vast majority of the time, everyone who wants or needs to be connected to the Wi-Fi network can do so, and do so reliably, get that signal. And what's interesting is we see this shift not just in schools where there's a prevalence of mobile devices. We're starting to see this in the business world as well. More people now have tablets that they're using for work. Their smartphones are coming in with the Wi-Fi turned on. They're connecting to your network as well. And a lot of companies have moved from desktops to laptops, which may or may not be docking. And even if they're docking, they may use the Wi-Fi network rather than having the expense of physically wiring everyone's machine when they're at their desk. And so, densities become more of an issue, even with our small and mid-sized business customers, as well as our K-12 and our higher education customers. Now, as we move forward, people have put in enough access points that the density's there, at least in theory. But what starts to happen is we start to see performance hits, and we start to see reliability issues. More often than ever before, we get calls from our customers and our clients saying, folks are getting bounced off, or there's a glitch, right? Or I was on a phone call and got disconnected, and the service says it wasn't their fault. What's going on? And so now as we move forward, it's not just about making sure everyone can access and that you've got enough capacity. It's how well is it performing and how reliable is it for you? And so when it comes to Wi-Fi and dealing with signal, the struggle is real, as the T-shirt says. And we see that for a couple of challenges, some of which I've already mentioned. One is the device count, right? Even in an office environment right now, we're finding the average number of Wi-Fi connections per user running, where it used to be, between 0 and 1, it's now running between 1.5 and 3, depending on the company and the environment. And yet we have companies where people's desktops now use the Wi-Fi. They might have a laptop or a Chrome device that they travel with. And when they come into the office, their tablet or their phone that's there will connect as well. And we see that, not just, with the traditional mobile devices, but as more businesses start using Internet of Things and having sensors, whether it's for the HVA system or your lights, or security services, or you're running a distribution center or manufacturing plant, all of that comes into play as far as the device count trying to access your Wi-Fi networks at any one point in time. And then we have other factors that really come into place, particularly, and these vary based on your environment. One of the things we see is mobile hotspots, right? And this is both intentional and unintentional, right? So in hospitality, it's not uncommon for attendees at a conference to turn on their mobile hotspots so that their devices are using their cellular network rather than them paying for subscribing to the hotel network or the meeting network that's being presented in the conference center. What we also see is people using mobile hotspots in their car to share, one device's cell connection with other Wi-Fi devices in the car when they're traveling with business, acquaintances, or even their family members. And oftentimes people who use the mobile hotspot never actually remember or think to turn it off. It's just something that's there and is running. Well, when people walk into your office space or walk into your school or into your warehouse and their mobile hotspots are on, they're now broadcasting a Wi-Fi signal. And yes, the range is limited, but it's not limited enough that that it doesn't prevent it from interfering with the operation of your Wi-Fi network and your other business operations. The other type of network issue we see is particularly within small and mid-sized companies or companies that share buildings or office space with others. And that is interference from neighbors, right? Where you're running your Wi-Fi network, they're running their Wi-Fi network, but things seem unreliable. It turns out that your neighbors' Wi-Fi network could be directly interfering with your signal. And historically, people say, my performance is bad, or I've got dropped connections, or I don't have the density I need. Hey, if I'm not on one of the most basic wireless access points, there's a setting I can turn up the amplification, the gain on the antenna, and a lot of people do that. It provides a temporary fix. In actuality, those types of brute force or just adding more access points can create more problems over time than they solve, and I'll talk about that a little bit more in a moment. And so the challenges are out there. And part of the challenge is that, we like to think our Wi-Fi networks are static, but in reality, they're pretty dynamic because the usage patterns change with who's in the office, what devices are in the office, time of day, what's happening in neighboring offices. It's not necessarily enough just to do a one-time snapshot. So we looked and said, how can we help our customers, our clients, deal with all of this? And we looked and we said, hey, let's start offering Wi-Fi assessments. So we started looking at traditional tools and methods of doing it. And what we found is that the traditional way of doing the Wi-Fi assessment was to place a laptop or a mobile device on the network, on your Wi-Fi network, and use technology that's been around since Ethernet was invented, called sniffer, and sniff out the network. And it's great. We can measure with those tools. We can measure signal strength and other parameters. And the better tools even give you, if you enter in your floor plans, as you can sort of see in the image here, they can create a heat map that give you a good sense of coverage and density. And there are a couple of challenges with this, right? One is it is static. It is a point in time. And typically, and we see this a lot with schools, when schools bring in a company to do a Wi-Fi map or Wi-Fi assessment, they'll spend anywhere, depending on the size of the school, from $5,000 to $25,000 or $30,000. And those people will come in, they'll usually set up one afternoon, they'll monitor for a day, and then they'll go back and analyze the data and create the heat maps. And so it's static, and it really captures only one point in time. It's a limited scope in that it is focusing on your networks, so you're not getting, and because it's static and limited in scope, you're not getting reliability metrics, and you're not getting enough performance metrics to really give you good guidance. The other thing is that these assessments give you the assessment, but they don't tell you how to fix it. What do I need to change to make my environment, my Wi-Fi, more reliable, perform better, with the density and the coverage I need? And finally, these are expensive. As I said, our schools who've gone out and hired IT firms to come in and do these assessments are paying anywhere, depending on the size of their building, from $5,000 up to $25,000 or even $30,000 for a one-time snapshot. Typically, when we sort of took the data we gathered and averaged it out, they're paying $1.50 per square foot of space to get that assessment done. So we saw and started looking for a solution that really gave us a new approach, which was more a realization that we should be monitoring and doing analysis of Wi-Fi. And what we looked for in our solution, what we found, was a solution that can give you complete Wi-Fi ecosystem visibility. So it's agnostic. You're not relying on the data that's coming from the access points through the vendor-controlled management console. It's agnostic to what vendors and equipment are running. It's a completely separate way of monitoring that doesn't interfere with the ecosystem and doesn't create traffic that interferes with an accurate assessment. We wanted to have intuitive detection and notification of Wi-Fi problems. And this deals with the static versus dynamic nature, right? So yes, we can use the solution that we're presenting today to do a single assessment or do periodic assessments, but it can also be set up in a permanent or semi-permanent function and watch over a long period of time where you can set alerts and thresholds to get notified when a problem exists. So for example, in a school situation, if you have 3 classrooms that happen to be taking exams and doing online quizzes or exams at the same time, you might see an issue with Wi-Fi performance in that area of the building and go investigate it and talk to the educators what's going on and adjust it so that should that just happen again, they won't have problems. We also wanted to automate solution resolution. And this is the hard part. Most people are not electrical engineers and don't understand signal physics and signal dynamics. And so we wanted to find a solution that had a data engine and a solutions engine that could actually analyze, grade the problems as critical, major, minor, and not only identify what's wrong, but suggest root cause and suggest corrective action so you know what to do. We wanted to have security breach detection, and since our solution involves putting an independent sensor out in to hear all the Wi-Fi signals, we wanted to say, hey, let's use that sensor for remote testing so that if there might be an issue with the Wi-Fi network, we can run basic tests remotely without having to move to that part of the office or drive to that building in a campus situation, or even take the elevator to another floor to deal with it. And we did find a solution that sort of meets all this requirement. And what we like about it is, well, the sensors that we put in, whether it's ongoing for continuous monitoring and analysis or periodic or one-time assessment, they actually read every Wi-Fi signal, not just the ones that you're using. So we catch those external interferences that I talked about earlier as a way of doing it. So what I want to introduce you to is Wyebot, or known as the Wireless Intelligence Platform, and I want to take a look at it to give you a sense of what we mean by having this great solution. So let me just change over my screen here. Okay, so what you're looking at now is actually, it's a test environment. It's actually looking at Wyebot's own offices, but this is a live sensor out there. If we had multiple sensors in the sensor status area in the center left of the screen, they would be listed, but you can see right now we have sensors, one of which has a major outage. And when we look at what that one sensor is covering, it's picking up 14 access points with 43 connected devices, 23 SSID or Wi-Fi networks out there, a pretty heavy client distribution off the 2.4 gigahertz or the older protocols, as opposed to the higher speed 5.0 gigahertz protocols. And we've logged, since this has been up and running, we've done a reset, 506 events. And let's take a little bit of a look at what that means, right? Now, this is an example of continuing sensors. So this dashboard will actually change over time as conditions on the ground change, which is why it's great that we can actually set alerts. And so actually, let me jump in and say, look, we've only set up 3 alerts. We can always add an alert rule here. Okay, and we could, use, say, I want to know if any of my devices on the 5 gigahertz are using the lower channel widths, right? So we just add that alert in, it's enabled. Okay, we can edit that alert, we can delete it, and let's go back to the dashboard and we'll go in and look at events and alerts later, right? But what we can see by looking at this sensor is that the sensor currently detects 6 major issues and 2 minor issues. Now we're picking up 14 access points, but if I change the filter to only our SSIDs, we see that we're only running 3 of those 14 networks, right? Same thing with the number of Wi-Fi clients. There are 43, but if we only look at our networks, we only have 7 people spread over those 3 networks. And even client distribution, there's a lot of people on the older protocols, but if we only look at our networks, 85% of us are on the high speed, and there's only 1 user who's on the lower speed. Maybe we want to switch them over. And so it goes through with the filtering. But most importantly, what I want to show is the issue detail. So here we've got color-coded major and minor issues, and you can see by scrolling through, what I'm getting here is not just the problem, but a solution, right? So here's one, right? Client device is unable to join the wireless due to an incorrect pre-share key, which means there's an access point out there that is, it actually turns out that it's hidden, that's publishing a pre-share key that's incorrect, or people haven't updated the pre-share, the pre-share key's been changed and they can't get to it. Let's look at another issue. Another issue is the high channel utilization detected on the network. We're looking at utilization of 65, 25 of which is for management, which is pretty high. And this is on the the 2.4 gigahertz band, and we're using 44% of the available bandwidth. That's high enough to start impacting performance in a way that is noticeable to people, right? So there's more info on it. We could go look and get a more detailed breakdown if we wanted to, but you can see that we're getting more than just, hey, you've got this problem. Here's a way to solve the problem and address those issues and improve performance. And so it really gives you a powerful tool. And again, as I mentioned, there's a newer version coming out with more tests, but you can run remote tests from that sensor on devices. You can look, we actually don't have any that we've run to look at, but you can look at the results and track them. You have a lot of flexibility. Now, remember when I talked about creating events? Here's a list of events that we're flagging, right? So here we say, oh, I just created this event, access point on the 5 gigahertz band with 40 megahertz width detected. We actually have found some of these, and it appears that there's 3 devices that might actually be triggering that alert, right? Here's one, a previously discovered access point is no longer detected. Someone removed something from the network. Here's one where the packet retry rate is too high. Again, that packet retry will indicate a connectivity issue, a density issue, or even, or more importantly, a performance issue. And so this is affecting performance and reliability. Here's overhead is too high, meaning that these particular devices, the overhead is hit 25%, 64% of the packets are beacons. That probably means that the wireless access points are competing with each other to connect to the user devices, and there's so much overhead it's going to hurt a user's ability to connect reliably and have good network performance. So again, you get the information and you get the recommendations on how to solve the problem. And granted, these can be highly technical recommendations, and for many small and mid-sized businesses, the recommendations may not be able to be implemented with the equipment you have. So for example, in our office, when we first installed this and ran this, we found that we had too much conflict along the old 802.11 protocols, the 2.4 gigahertz speeds. And when we looked at it, the recommendation was to bandwidth steer devices up to the 5 gigahertz network. Well, it turns out that we have currently we're testing the small business edition of the Linksys wireless access points. They're very simple setup. They're designed to be easy to use for small business, so they don't have the ability to do bandwidth steering. So our solution, we got more data that said, hey, wait a minute, all but one device has the ability to run at the 5 gigahertz network. We actually turned and shut down our 2.4 gigahertz network altogether, and all the devices now connect to the 5 gigahertz, except for that one. And it was an old device. We decided to retire it. So we improved our reliability and our performance. We also found that every other wireless network in our small office business was at the same speed on the same channel interfering with each other. And so by shutting that down in our environment, our wireless performance has dramatically improved, noticeably to the end user. And so that's the value this brings. So how does this all work? At the high end, we offer a managed service. We'll map out your location. We'll put each sensor is good for a radius that includes about 10,000 square feet, up to that amount, depending on the construction of your building or your office space. We can put in one or more sensors in fixed locations and give you continuous monitoring. That lets us do historical and trend analysis. We can have alerts that generate service tickets. And obviously, we can come in with periodic reviews, reports, and recommendations. And you get the benefit for your IT team or for us to do it for you of remote network diagnostics. If you're not interested in us doing all the legwork, again, how many sensors you need to subscribe in your environment, you can just subscribe to the monitoring, and you have access to the data. We still have access to it as well if you want assistance with it, but you work directly and you get the recommendations from the system. Additionally, for many small businesses, you don't need your environment may not be dynamic enough to warrant continuous monitoring and that cost. So we can come in and do periodic assessments 3 or 6 times per year. We actually send you the sensors in a secure case. You plug them in, they self-boot and self-connect. We run for a couple of days to get a longer history of information. We shut down, give you a shipping label to send the devices on their way to the next customers, and we then turn around and take the results and give you a report with recommendations on what to do. Whether you have us help you with those recommendations or your other IT providers is purely up to you. And of course, we can do a one-time assessment. And here's where we add a lot of value. And that, remember I talked about most schools are paying $1.50 per square foot. When we look at the scope of what these sensors cover and what they can do, we're able to do the same assessment and give you those recommendations for about 10 cents per square foot. So significantly less expensive because the technology and the cloud-based engine behind the sensors is so much more than what's currently available, and you don't need to buy or rent the software to do it. We just put those on site. So here's the offer. If you're interested and want to kick the tires, we're happy to do a free initial assessment, send you a device for a week on a trial. We're also offering savings on our periodic assessments and our monitoring and managed service subscriptions. The rate of the savings and the discounts really depend on the number of sensors you needed and the term that you agree to, whether it's month-to-month, annual, or a 3 or a 5 year term. So if you have interest in any of this, please let me know. My email address and phone number, that 4071 number in the lower right-hand corner, is direct to my desk. I will tell you I respond better to email, much better than I do to voice messages. So best to email me or just shoot a note over to info@cumulusglobal.com. At this point, it doesn't look like we have any questions queued up. And so I want to thank everyone for joining us here today for this session. I hope we provided a little better understanding of some of the challenges, particularly for small, mid-sized companies, for schools, for hospitality, retail locations that really rely, warehouse and distribution, that really rely on Wi-Fi for reliable business operations and a good user and customer experience, and a way that we can monitor and manage and ensure that Wi-Fi is performing optimally at a much lower cost than the traditional techniques of assessment and recommendation and reconstruction. So thanks for joining us today, and have a great day.